Assalamu alaikum warahmatullah. This is experiment 4. The name of this experiment is grain size analysis, sieve analysis of coarse grained soil sample. Grain size analysis is universally used in engineering classification of soil. The three general procedures of analysis are sieve, hydrometer, and combined analysis. In this experiment, our main objective is to determine the grain size analysis of a soil sample and present the tested data in a grain size curve. You can see there are number of equipments arranged on the table. You can see the balance machine, the shaking machine, the number of sieves or set of sieves, another balancing machine, a stopwatch, and the brush. First of all, we have to take the weight of the sieves. You can see we are taking number 4 sieve, and the weight of this sieve is 335.7 gram, and the opening of this sieve is 4.75 millimeter. This is number 8 sieve, the opening is 2.36. The weight of the sieve is 358.7 gram. This is number 16 sieve, the weight of the sieve is 313.6 gram. Now we are taking number 30 sieve. This is 325.5 gram. This is number 50 sieve. The weight of this sieve is 309.1 gram. Now we are taking 100 number sieve, and the weight is 307.4 gram. This is 200 sieve, and the weight of this sieve is 288.3 gram. This is pan, and the weight of this pan is 302.2 gram. So we are taking the weight all of these sieves. Now we have to take the weight of the soil sample, which we keep on the sieve. So we are taking the weight of the soil sample. This is 100 gram, but the original procedure is you have to take 500 gram. We are pouring the soil sample in the sieve. Now we are taking it to the shaking machine. As there is no retained on the number 4 sieve, so we are keeping it out from the series of the sieves. You can see we are locking the shaking machine with the set of sieves. We are starting the machine, shaking machine, and you have to count it down to 1 to 10 minutes. After completing the shaking, we took all of these sets to the balancing machine again, and after that we are taking the weight again. And if we deduce the weight from the previous one, then we can get the weight of soil retained in each sieve. And in our calculation, we will see how we calculate the percent of soil retained in each sieve, which is very important to get the fineness modulus. So we are taking the set of sieves to the table, and after that we are taking the weight. This is 0, that means the previous one, that means 335.7 gram. So there is no retained of the soil sample in that sieve. we are taking the next one, that means number 8 sieve. Now the weight is 358.7 gram. So and now we are taking it to the sieve, and the amount is 314.2 gram. So the amount is for 30 number sieve is 333.8 gram. The amount in number 50 sieve is 326.3 gram. The amount of this sieve, that means 100 number sieve, is 329.4 gram. The amount in 200 sieve is 308.8 gram. And last of all, pan, the amount in the pan is 334.3 gram. So when we took all of these results, we calculate it in our table to get the FM. Now we are going to the experimental part or the calculation part, and this is your related theory. And in your assignment portion, you have to keep all of these. You can see the objectives are there, and the equipment, the materials, and the experimental procedures are also there. You can see the step-by-step procedure is given here, and this is the final chart which was previously shown in the video. You can see the number of the name of the sieve, and this is the opening or the diameter of the opening of each sieve. That means in number 4 sieve, the opening of the opening is 4.75 millimeter, and you can see the weight of these sieves which was previously taken in the video. This is after shaking the amount or the weight of sieve plus soil. This is the weight of soil retained, and we are assigning it as column 5 for the next column, as this is 1 2 3 4 5. And you can see the weight of the soil retained is getting by deducing from number 3 column to number 4 column. So this is the difference between number 3 column and number 4 column. You can see the actual amount of soil retained on each sieve. So if you sum all of these sieves, you can get the total amount of soil which was previously taken as the sample. This is 100 gram. And after that, you have to take the percentage of retained. That means the how much percent retained in each sieve. Suppose you have to take number 16 sieve. This is 0.6 gram. So the percent of soil retained in number 16 sieve is 0.6 divided by 100 into 100%. That means 0.6. All of these are same as we took 100 grams as a soil sample, and this is also the 100 for the percentage. So the amount of these are same here. After that, you have to take the cumulative percent of soil retained. That means this you have to sum all of these, like 0 to 0, 0 plus 0, 0, 0 plus 0.6, 0.6, 0.6 plus 8.3, 8.9, 8.9 plus 17.2, 26.1, 26.1 plus 22, 48.1, 48.1 plus 20.2, 68.3, 68.3 plus 31.7, that's 100. So you have to remember that both this and these would be same. If this is not same, so you have to think that you are wrong in any of steps, any step of the calculation. And after that, you have to take the percent final. This is percent retained and this is percent final. So if you deducing this column by 100, then you can get the value, like 100 minus 0, that means 100, 100 minus 0, that means 100, 100 minus 0.6, 99.4. Similarly, all of these you have to take, and this is 100 minus 100, that means 0. So why we are taking this percent final? We have to take this value in the graph, but before the graph we have to calculate the fineness modulus. the fineness modulus, the equation of the fineness modulus is summation of cumulative percentage retained on specified sieves divided by 100. This is always 100. This is no, there is no relation between this 100 and this 100. So the summation is cumulative percentage retained on the specified sieves. So this is specified sieves. So what is the meaning of the specified sieves? The specification which was previously shown in the ASTM. In our ASTM standard, these sieves or this number of sieves are prescribed to get the FM. Number 4, number 8, number 16, number 30, number 50, number 100. Not 200, not pen. So from 4 to 100, these are the standard sieve, and you have to take these values only. You can see the number 4 sieve, the retained of the number 4 sieve is 0, number 8 0, number 16 0.6, 30 8.9, 50 26.1, 100 48.1, and this is the amount here. So if you are calculating all of this and dividing it by 100, then you can get 0.837. That means the FM of this soil sample is 0.837. The lower the value of the FM means that this is very fine particle, and the higher the amount value of the FM indicates the coarse or the bigger size of the soil sample. After that, you have to take a semi-log paper where in the x-axis determines the sieve opening and in the y-axis determines the percent finer. This is this percent finer. So if you are putting all of these values, then you can get a curve. I repeat, this graph is semi-log graph paper, not a normal graph paper or not the log graph paper. And after that, you have to take some values from that graph, like number 10, number 30 and number 60. You have to take the straight line from that 60 to that curve and taking the value of the sieve opening of these 60, 30 and 10 simultaneously. So what does that mean? That means the percent finer of 60%, that means the 60% finer in which diameter? 0.19 millimeter. 30% finer in 0.07 millimeter. 10% finer in 0.019 millimeter. You have to calculate CU and CC by using these equations and by using the values like D10, D30 and D60. You can see the calculation is here. So what is CU and CC? If you are scrolling up to the theory, you can get the idea of CU and CC. That means CU implies a uniform grading. If all of the particles are the same size, CU is unity. A granular soil is termed well graded if CC is greater than or equal to 1 but less than or equal to 3. CU is greater than 6 in case of sand, and if CC is greater than or equal to 1 but less than or equal to 3, and Cu is greater than 4 in case of gravels. When these requirements are not met, the soil is termed as the poorly graded. So you have to take the Cu and Cc value to classify the soils. After classifying the soil, this is termed as the well graded soil, as Cu is greater than 4 and Cc is between the 1 to 3. So the soil is well graded. This is the end of this experiment. Assalamu alaikum wa rahmatullah.